everyone. Today I am going to take lecture of Discrete Mathematics chapter number 4 and the name is the algebraic structure. So we have already seen in our previous lecture what is the coset, left coset, right coset, normal subgroup and the Lagrange's theorem. So our next theorem is depends on the cosets, left coset and the right coset. Okay. So the theorem is that if A and B are any two elements of a group G star. Star is any operator, okay, and H is a subgroup of G. Then H star A is equal to H star B. Implies A star B inverse belongs to H. That means what here? H star A is equal to H star B. So A B inverse belongs to H. Okay. And the second one is what? Second one is if we write here A star H is equal to B star H. Implies what? E inverse B belongs to H. So don't be confused here. If you write here H in the left hand side, so this is the right coset. So A B inverse belongs to H. Okay. And in the second one, we write the capital H in the right hand side. Okay, so this is the left coset. So A inverse B belongs to H. Okay, so according to this theorem, we use the number 1 and prove that this condition are satisfied or not. Okay, so let's start the proof. So here, according to proof here, the H is a subgroup of G comma star. Okay, that means what? H is also a group. Got it? Because of H is a subgroup of G star, so H is also a group. Next one is what? If H is also a group, that means what? We can say that H comma star is a group. We can say that. Okay, so if H is a group, so obviously the four properties are also satisfied: the closure property, the associative property, the identity, and the inverse. Okay, so here, for example, if we write here E belongs to H, for example, so here we write E star A belongs to H star A, the property of the coset. Okay, so E star A, that means what? A belongs to H star A. Why? Because of E is the identity element and H is the group. So A belongs to H star A. This is our main equation, you can say that. Okay. So for proof of the first one, we take the LHS and prove that the right hand side. Next one is we take the right hand side and prove that this equal to left hand side. Okay. So first we write here the LHS. Okay, so according to LHS, H star A is equal to H star B. Okay, H star A is equal to H star B. So implies A belongs to, because of H star A is equal to H star B, and according to this equation, A belongs to H star A and H star A and H star B equal. So obviously A belongs to H star B. So we write here A belongs to H star B. Okay, so here employees, for example, we multiply here according to B inverse, that means A star B inverse, for example. So here we write H star B inverse. Okay, that means here A star B inverse belongs to H star B inverse. Okay, and H is a subgroup of G. So elements and the inverse of elements, if we apply here any operator, so B star B inverse is equal to identity element. That means what here? A star B inverse belongs to H star E. Okay, so here A belongs to B inverse belongs to H. Okay, that means A star B inverse belongs to H. So this is the RHS. Okay, here according to prove that for first one, if we take here H star A is equal to H star B, then we prove that A star B inverse belongs to H. That means first satisfied. Okay, second one is what? Here this is the identity property. Identity property. Okay, next one is what? We take here the right hand side. Okay, that means RHS. So right hand side is what? A star B inverse belongs to H. Okay, so A star B inverse belongs to H. That means what? Here, for example, we write here H star. A star B inverse is equal to H. We have already proved that here H star, this is the A star B inverse is equal to H. Because of here, we have one theorem according to our syllabus. If H belongs to H, then H star H is equal to H. Okay, so A star B inverse belongs to H. We have already taken here the A star B inverse belongs to H, so we write it this side. Okay, so here according to H star A, so H star A star B inverse. If we write here the star B, so here we write the H star B. Got it? So next one is what? H star A star B inverse star B is equal to H star B. Okay, for the associative property. Next one is what? H star A star E. Got it? So here H star B. Okay, next one is what? Next one is H star A is equal to H star B. Because of E is the identity element. Okay, here we write the bracket. E is the identity element. That means what? Here we write the, we find out the LHS. Okay, so from equation 1 and equation 2. Equation 1 and equation 2 is what? If we take here, we consider the H star A is equal to H star B. This is the true. So we find out A star B inverse belongs to H. Okay, and if we take here A star B inverse belongs to H, this is the true condition. So we find out H star A is equal to H star B. Okay, so from equation 1 and 2. From equation 1 and 2, we write here H star A is equal to H star B employs A B inverse belongs to H. Okay, so this is very important theorem according to your coset is the quotient group. So let G comma star be a group and let N comma star be a normal subgroup of G. If A belongs to G, then N star A is right coset of N in G. Also, capital N being normal subgroup of G. So we have already seen in our previous lecture what is the definition of the normal subgroup. Okay, so normal subgroup, that means very easy definition here. The left quotient and the right quotient are equal. Then we can say that this is a normal subgroup. So here we consider G star be a group and N star be a normal subgroup of G. That means what? Here the left quotient and right quotient both are satisfied according to N star. Okay, so if A belongs to G, then N star A is right quotient of N in G. Because of here, in that time we considered the subgroup capital H, but here we consider the capital N. So capital N we write here in the left hand side. So this is the right quotient exactly. Okay, so N star A is right quotient of N in G. Also, capital N being normal subgroup of G. Each right quotient of N in G will be a right quotient of N in G because N is a normal subgroup. Okay, so what is how we define the quotient group? So G by N is equal to N star A such that N belongs to G. Okay, so G by N is called the quotient group. That means quotient group, that means what? G by N. So N is a normal subgroup and G is a group. So we take here the one element belongs to G. So N star A such that A belongs to G. Okay, so according to this quotient group, we solve here the one example and we are given in find out the G by N, that is quotient group and the operator is star is a group. Okay, so first we find out the four properties. Because of we prove here the G by N and the operator star is a group. That is what first we find out the closure property. That means we consider the two elements belongs to G by N. Because of here the group here we are given in the set, you can say that this is the set is G by N. Okay, so if A and B belongs to G by N, so if we consider the operator, that means A star B also belongs to G by N. This is the closure property. Second one is the associative property. So we consider the three elements belongs to G by N and we find out the A star, B star, C. So we take here the any two elements in bracket. So in equal to we change this bracket. Okay. Third one is the identity. That means the E is the identity element and fourth one is the inverse property. Okay. So let's start. First one is the closure property. So here we write the solution or you can say the proof. If number one is the closure property. Closure property. Okay, and here you define G by N. That means what? G by N is equal to N star A such that A belongs to G. This is the proof G by N. Okay, next one is the closure property. So closure property, that means what? If or for all A comma B belongs to G. Okay, then N star A and N star B belongs to G by N. Because of here we find out that G by N is a group. Okay, so here we consider N star A and N star B belongs to G by N. So why we consider here N star A and N star B? Because of here we define G by N is equal to N star A and A belongs to G. So first we write here A comma B belongs to G and N star A comma N star B belongs to G by N. So what is the closure property? Closure property is A star B also belongs to G by N star. Okay, so here N star A star N star B. Okay, so that means what? That means here N star A star B belongs to G by N. Okay, that means what? A star B belongs to G. Okay, so here this is the closure property. That means G by N satisfies the closure property. Okay, second one is the associative property. So second property is what? Second property is associativity. Associativity. Okay, so what is the associative property? Associative property, that means what? N star A star N star B operator N star C. Okay, is equal to what? Is equal to, we prove that N star A star N star B and bracket close star and star C. Okay, so we tag here the LHS and prove the right hand side. So LHS, that means what? Here we write the LHS. Okay, so LHS, that means what? Here we write the N star A star N star B star C. Okay, according to closure property. So you write here in the right hand side with the help of closure property. Okay, so here N star is, that means what? Here we write N star. Okay, A star B star C. Okay, next one is what? N star A star N star B, and here we write in the bracket star N star C. Okay, so this is satisfy the associative property. That means G by N closed with associative property. Okay, and here you write here the one more step according to this N star A star B star C. Okay, you write here. Got it? Okay, so this satisfy the associative property. Third one is what? Third one is the identity, and fourth one is the inverse. So if identity and inverse also satisfy, then we can say that G by N is a group. Third property is existence of identity. So if we have N is equal to N star E belongs to G by N, because of E is the identity element. Also if N star A belongs to G by N, this is the definition of the quotient group. So then N star A star N star E is equal to what? N star A operator E. So A star identity element, that means the A. So if we check here the N star A star any identity element, then we get the element itself N star A. So normal subgroup N itself is the identity of G by N. That means this satisfies the existence of the identity. Fourth one is the existence of inverse. Okay, so existence of inverse, that means what? Let N star A belongs to G by N. Okay, then N star A inverse also belongs to G by N because of G is a group. Okay, so N star A star N star A inverse is equal to what? Is equal to N star A star A inverse. Okay, so A star A inverse is equal to E. So N star E. That means what here? N star E. That means this is the identity element N star E. Okay, so here this is the what? This is associativity property. Associative property with the help of, and next one is the inverse. Okay, inverse, that means because of this is the element of the group A and A inverse. Okay, that means what? If N star A operator N star A inverse is equal to what? N. Okay, so this G by N satisfy the inverse property. Okay, so we find out here the closure property, associative property, identity property, and the inverse property. So we can say that G by N comma star is a group. Okay, this is our final answer. Okay, so I will continue this topic in our next lecture. Thank you for watching this video.